Since the earliest civilizations, people have looked toward the night sky searching for meaning. Long before telescopes existed, the stars guided travelers, marked the changing seasons, and inspired stories that were passed from one generation to the next. Although those ancient cultures interpreted the heavens in different ways, they all shared one belief: the universe was far greater than anything they could fully understand. As centuries passed, curiosity replaced mythology with observation. Astronomers began recording the movements of planets, predicting eclipses, and discovering that the sky followed precise mathematical patterns. Every breakthrough strengthened the idea that nature was governed by laws waiting to be uncovered. Yet history has revealed something remarkable. Each time humanity believes it has nearly solved the universe, a new discovery expands the mystery even further. Earth was once thought to stand at the center of creation until science showed that it circles an ordinary star. That star turned out to be one among hundreds of billions inside the Milky Way. Later, astronomers learned that our galaxy is only one member of an enormous cosmic population stretching across the observable universe. Instead of becoming smaller, the mystery kept growing. Today, that journey has entered a new chapter with the James Webb Space Telescope, the most powerful space observatory ever built. Unlike traditional telescopes that mainly observe visible light, Webb was designed to detect infrared wavelengths. This allows it to capture extremely faint light emitted billions of years ago by some of the earliest galaxies in existence. Because light takes time to travel, observing these distant objects is like opening a window into the ancient past. Some of the photons reaching Webb today began their journey when the universe was only a small fraction of its present age. To collect these incredibly weak signals, the telescope operates nearly 1.5 million kilometers from Earth at the Sun-Earth L2 point. Protected by its enormous sunshield and equipped with a segmented gold-coated mirror, Webb remains cold enough to detect heat signatures that would otherwise be impossible to measure. Its mission is not simply to photograph distant objects. It is to reconstruct the history of cosmic evolution using the oldest light still traveling through space. Even before Webb, astronomers had already discovered that the universe was far richer than anyone imagined. The famous deep field observations from earlier telescopes revealed thousands of galaxies hidden inside areas of the sky that appeared completely empty. What looked like darkness was actually filled with islands of stars scattered across billions of light years. Those discoveries transformed astronomy forever. But they also raised a difficult question. What existed even earlier? The answer required a telescope capable of seeing farther back in time than any instrument before it. That is exactly what Webb was built to accomplish. As its first observations arrived, scientists immediately noticed something unexpected. Many of the earliest galaxies did not appear as small, chaotic collections of newly formed stars. Instead, several looked surprisingly bright, massive, and well-organized despite existing only a few 100 million years after the Big Bang. Some displayed evidence of rapidly forming stars. Others appeared far more developed than many theoretical models had predicted. These findings did not overturn modern cosmology, but they encouraged researchers to re-examine how quickly galaxies may have assembled during the universe's earliest era. Another important surprise came from spectroscopy, the technique astronomers use to identify the chemical composition of distant objects. By separating light into its individual wavelengths, Webb detected elements such as carbon and oxygen inside extremely ancient galaxies. These heavier elements cannot be produced during the Big Bang itself. They are created inside stars and released into space after those stars reach the ends of their lives. Their presence suggests that multiple generations of stars had already formed and evolved surprisingly early in cosmic history. This paints a picture of a young universe that may have progressed much faster than scientists once expected. Rather than slowly building complexity over billions of years, The first galaxies may have experienced intense periods of rapid growth almost immediately after the first stars ignited. Naturally, these observations have inspired new questions. How did galaxies mature so quickly? Were conditions in the early universe different from current models? Or are there processes still waiting to be discovered? Astronomers continue investigating these possibilities with every new observation. And while these ancient galaxies are extraordinary on their own, Webb is also revealing something even greater, a hidden cosmic framework connecting galaxies across unimaginable distances. That immense structure, known as the cosmic web, is beginning to reveal how the universe organized itself after the Big Bang. And understanding that invisible architecture may become one of Webb's most important scientific achievements. If galaxies were scattered randomly throughout space, the universe would look very different from what astronomers observe today. Instead, when scientists map millions of galaxies across enormous distances, a remarkable pattern begins to emerge. These galaxies gather along gigantic strands stretching across hundreds of millions of light years. Between them lie vast regions containing very few galaxies at all. Together, these filaments and empty voids create an enormous three-dimensional network known as the cosmic web. This hidden structure acts as the universe's framework. Galaxies, galaxy clusters, and enormous clouds of gas are not distributed by chance. Gravity gradually pulls matter toward these invisible filaments, where new galaxies continue to grow and evolve over billions of years. One of the biggest mysteries surrounding the cosmic web is that much of its structure appears to be supported by something humanity cannot see directly. Astronomers call this invisible component dark matter. Unlike ordinary matter, dark matter does not produce light or absorb it. Scientists cannot observe it with telescopes in the traditional way. Instead, its existence is inferred through its powerful gravitational effects on galaxies and galaxy clusters. Without dark matter, many of the large-scale structures visible across the universe would be extremely difficult to explain using current theories. The James Webb Space Telescope is helping scientists investigate this mystery in greater detail than ever before. By observing galaxies from different stages of cosmic history, Webb allows researchers to compare how these structures changed over billions of years. Each new observation improves computer simulations describing how gravity shaped the universe after the Big Bang. Yet every answer seems to reveal another question. Some ancient galaxies appear larger than expected. Others seem to have formed stars at astonishing rates. Several contain surprisingly mature chemical compositions despite existing during the universe's earliest eras. These discoveries do not overturn modern cosmology, but they encourage scientists to refine existing models and better understand how quickly complexity emerged after the universe began. Webb's mission extends far beyond distant galaxies. It is also transforming the search for planets orbiting other stars. When an exoplanet passes in front of its parent star, a tiny portion of the starlight travels through the planet's atmosphere before reaching the telescope. Different gases absorb different wavelengths of light, leaving behind unique chemical fingerprints. Using this technique, Webb has detected molecules such as water vapor, carbon dioxide, methane, and other atmospheric compounds on several distant worlds. These measurements provide valuable information about planetary environments, temperatures, and atmospheric chemistry. Although no confirmed evidence of life has been found, scientists can now evaluate whether distant planets possess conditions that may be favorable for habitability. Only a few decades ago, this level of analysis seemed impossible. Today, it has become routine scientific research. Perhaps the most remarkable achievement of the James Webb Space Telescope is not a single photograph or discovery. It is the new perspective it gives humanity. Every image reminds us that the universe is far older, larger, and more complex than previous generations imagined. The light collected by Webb has traveled across billions of years before reaching its mirrors. Those ancient photons carry information from a time when the first stars were illuminating the darkness and the earliest galaxies were beginning to take shape. By studying that light, humanity is reconstructing chapters of cosmic history that were once believed forever beyond our reach. Yet every breakthrough also reminds us how much remains unknown. What is dark matter? How did the first galaxies grow so quickly? Why did some supermassive black holes appear so early in cosmic history? And could future observations reveal entirely new physical processes that scientists have not yet imagined? These questions continue driving one of the greatest scientific adventures in human history. The James Webb Space Telescope is more than an observatory. It is a time machine built from science and engineering, allowing humanity to explore the earliest moments of the universe with extraordinary precision. Every observation pushes the frontier of knowledge a little farther. Every discovery opens another mystery. And as Webb continues its mission, it reminds us of one timeless truth. The universe is not simply a place we observe. It is a story we are still learning to read, and each new chapter brings us closer to understanding our place within the cosmos.